Okay, in this part of the video, we are going to write our equations given a table. So first of all, to make sure that we know that this is linear, my function table will have a constant rate of change. So we're going up to, up to, up to, up to, and then our x values are in consecutive order and they are just increasing by 1. So this is how I know that this is a linear function. Therefore, my slope is rise over run. And then my b value is the y-intercept, which is given. So when you are given the y-intercept and you can find your slope, you're definitely going to use slope-intercept form. And now we just need to put it all together. And we get 2x minus 8. Okay, so again, this is going to be linear, but to show that, we're going to see that it has a constant rate of change. You can see my x values are not consecutive. This is going down 1, down 1, down 1, down 1. So my outputs, the change of my y values is minus 1, and the change of my x values is plus 3, plus 3, plus 3, plus 3. So I do have a constant rate of change, which is negative 1 over 3. I do not have my y-intercept, so I'm going to use point slope. So we can just choose any point to plug in for our ordered pair, y1 and x1. So we have y minus y1 equals my slope, and then we have x minus my x value. Now let's distribute the negative 1/3, and then we're going to get y by itself. This should be a minus right there. Now we need to get y by itself, so we're going to add 7, and we have y equals negative 1/3 x plus 8. Or if we like, function notation, and we have it in standard form. Now let's take a look at quadratics. So it depends on what we're given. So my x values are in order. I do have the y-intercept, so I'm going to use standard form. So we need an a value, a b value, and a c value. Our c value is 4, and now we're going to find the a value. So from negative 16 to negative 5, we are increasing by 11. From negative 5 to 2 is an increase of 7, an increase of 3, and a decrease of 1. Now we're going to find the second difference. This is going down by 4, down 4, and down 4. So the a value is the second difference divided by 2, so that gives us negative 2. Now we're going to use a point other than the y-intercept. We've already used that point. So we can just choose any point you want for x and f of x. So my f of x value is going to be 5. Again, I'm using standard form equation. So I plugged in 5 for f of x. My a value is negative 2. The x value we're using is negative 1. And my c value is 4. I square negative 1, multiply that by negative 2. I multiply b times negative 1. And then I combine like terms. Negative 2 plus 4 is plus 2. Solve for b. Divide each side by the negative 1. And my b value is negative 3. So when I write my equation in standard form, I get my a value of negative 2, my b value of negative 3, and my c value. So this is standard form. Okay, my x values are not in consecutive order, even though I'm given my y-intercept, but because these are not consecutive, I will not be able to find my a value, so I cannot use standard form. But notice I have the x-intercepts, the roots, So I am going to use factored form. I don't know my a value, so I'm going to say x minus -4. And then we have x minus 2. We're going to use a point other than the point we've already used. Let's just go ahead and use the y-intercept. I'm going to plug in -4 for f of x, 0 for my x value. Now let's simplify the right side. 0 plus 4 is 4. 0 minus 2 is -2, and we have our a. So we're going to multiply all that together. So we get -8 times a and solve for a. And now we're going to write our equation. Y equals 1/2 x plus 4 times x minus 2. Now it will probably ask you to put this in standard form. So we're going to distribute and multiply. So we're going to distribute x and 4. We get x squared minus 2x plus 4x minus 8. Combine our like terms and multiply by 1/2. And now we have standard form. Okay, on this one, we do have the y-intercept, but our x values are not consecutive, so I cannot use standard form. This highlighted point indicates our vertex, and I don't have my root, so I have to use vertex form. So let's plug in what we have. It's going to be x minus my h value plus my k value. Let's pick a point. Let's just go ahead and choose the y-intercept to plug in for x and f of x. So I'm going to replace f of x with -7, replace x with 0, and simplify. This is going to be -6, but it's going to be squared, so that's 36a plus 2. Solve for a, subtract 2. I get -9 equals 36a. Divide each side by 36. And my a value is -1/4. So we get -1/4 x minus 6 quantity squared plus 2. Let's go ahead and convert that. We're going to expand the exponent first. You're going to be reminded with the grouping symbols at the very end, you will add in the 2. So when I multiply a binomial by itself, I get a perfect square trinomial. Let's not forget this is negative. -1/4, keep your work nice and neat. So I get x squared, and then I get -6x and another -6x, so that's -12x plus 36. Now I'm going to distribute the -1/4. Actually, at this point, you don't even need the parentheses, but I'm only multiplying -1/4 to my trinomial. And now I can bring in the plus 2. So my final answer in standard form is -1/4 x squared plus 3x minus 7. Okay, last couple of problems. We are going to do our exponential function. So here we first just need to find the b value. My x values have to be consecutive, and they are. And now I just have to do the previous over the current number. So 12/24, or we could just say 6/12, or 3/6. And then this gives us 1/2, 1/2, 1/2. So we have a constant ratio, which is our multiplier. So we have f of x equals a times 1/2 times x. And now we're going to plug in a point, or you can remember when it's in basic form that your a value will be your y-intercept, but let's just say you forgot. So we're going to plug in 3 for f of x. We're going to plug in 0 For x, anything to the 0 power is 1, so that's 1a, so a is 3. And our final equation is 3 times 1/2 raised to the x. Okay, let's take a look at, here's a function table. Our x's are in order. This time we are not given the a value, but we know what to do. We'll just plug in a point. So let's find the b value. So -8 over -4, -16 over -8, -32 over -16, and so forth. That does give us 2 all the way down, and we could keep going. So my b value is 2. Now let's just pick a point. I'm just going to pick 4, -4, so -4 for f of x, and 4 for x. We're going to expand, so this is 2 times 2 times 2 times 2. 2 times 2 is 4, times 4 is 16, so I have 16a. Solve for a, and I get a equals to -1/4. My final equation is -1/4 times 2 raised to the x.